Customers tell us the number one concern they have with plasma is poor hole quality. Two of the most common problems are hole taper, where the diameter at the top and bottom of the hole are not the same, and the presence of dings or divots inside the hole. Both issues prevent holes from being bolt ready and require costly secondary operations to correct. Hypertherm's patent-pending TrueHole technology eliminates these problems by using a specific combination of process parameters, which are determined by the nesting and process optimization software. After importing the CAD drawing into ProNest, the programmer assigns the specific material type, the thickness, and the amperage. The nesting and process optimization software nests the part and automatically applies the optimal torch motion routines and expert cutting techniques needed to achieve TrueHole quality, based on part geometry, including thickness, hole size, and amperage. And it does this automatically, even if you have parts with different geometries and multiple hole sizes within the same nest.
With any material?
No, TrueHole was designed for mild steel and has been optimized for as low as a 1-to-1 diameter to thickness ratio. Just to give you an idea how much information is being programmed, take a look at this list of code that has been generated just to cut one hole. It contains all the instructions for setting the process gas selection, gas flow rates, amperage, pierce methods, lead-in, lead-out techniques, cut speeds, and cut timing. These process parameters are all set automatically without any operator intervention. You can see how this would save considerable setup time on the floor and eliminate potential operator error, particularly if you have a complex set of parts, like this. It also ensures consistency. You get true hole quality across multiple shifts and multiple operators.
So you're saying my new operator on second shift can cut holes as well as my best guy?
That's right, as long as he's using TrueHole-enabled components. When the part program or nest is complete, it's converted to an NC file, and then it's ready to go to the CNC. Your machine operator then simply selects the part program file in the CNC. The Cut Pro wizard, which is built into the Hypertherm CNC, guides the operator step by step, including showing what consumables are needed for that job and even how to install them. The operator simply aligns the plate and is ready to go. The CNC then works with the torch height control and the plasma system to seamlessly complete the job. And because all of the operating parameters are displayed on the screen in real time, the operator can monitor the entire job.
Well, that's all pretty impressive, but how do you eliminate hole taper and minimize the ding?
By using a unique combination of switching shield gases, adjusting timing, and using optimal process parameters. Let's look at the process step by step. As the torch moves into position to pierce, TrueHole uses a combination of oxygen plasma and air shield gas to pierce the hole. Piercing with an air shield gas minimizes the size of the pierce hole and dross spatter. When in position, the torch pierces at the center of the hole, automatically adjusting for kerf compensation without shifting the pierce point. With traditional kerf compensation, the shape of the hole can get distorted. Hypertherm's nesting and process optimization software takes this into account and makes sure TrueHole pierces directly into the center of the hole. Once the pierce is complete, it automatically switches to an oxygen plasma shield gas for hole cutting. The auto gas console is what makes it possible to switch to a low flow rate of shield gas that has a lower nitrogen content. It then uses a lead-in speed that is specific to the hole size, thickness, and amperage to apply a semicircle shaped lead-in. As the lead-in completes, the torch switches to a faster cut speed for hole cutting. The hole cut speed, shield gas composition, and shield gas flow rate are optimized together to virtually eliminate hole taper. When it approaches the end of the cut, the current automatically begins to ramp down to provide the optimum amount of cutting energy to the remaining material in the hole. Then, as it begins its lead out, the current shuts off. But the torch still maintains its full velocity, automatically applying the optimal lead out length to avoid overburn of the hole surface. This combination of current ramp down timing and lead in and lead out techniques is what minimizes the ding and biases it to the outside of the hole. When hole cutting is complete, the torch automatically switches back to an oxygen air shield for contour cutting. This helps maintain nearly dross-free cuts and optimal productivity on longer contour cuts. The result? Bolt-ready holes with minimal, easy-to-remove dross.
It's pretty remarkable. A perfect fit right off the machine.
Virtually no taper, and dings are minimized and biased to the outside of the hole. No other competitor can offer this, and it's all achieved without any operator intervention. This patent-pending combination of optimized processes and the seamless integration of all components working together is what makes Hypertherm's TrueHole technology truly unique.